Good morning, everybody. So, in today's lecture, we will take up some more problems on Venturi meter and then move on to the next topic, Orifice meter and Pitarch tube. Straight away, I will take you to the whiteboard. So, in today's lecture, we are taking up some more problems on Venturi meter. And let me take straight away the first problem. A Venturi meter has its axis vertical. The inlet and throat diameters being 150 mm and 75 mm respectively. The throat is 225 mm above the inlet and CD is equal to 0.96. Petrol of specific gravity 0.78 flows up through the meter. The rate of 0.029 meter cube per second. Find the pressure difference between inlet and throat. The problem, if you look into it, venturi meter axis vertical. So it's a vertical, basically, it's placed in a vertical pipeline. Second thing is it is the throat is about 225 above the inlet, and the discharge is given, CD is given, and the flowing liquid is not water, it is petrol of 0.78. So the question is find the pressure difference. This is the thing. So now if you imagine how it is going to look like, actually if you see it, for example, in a vertical pipeline, if I draw like this, suppose this is a vertical thing, right? Now if you take it the venturi meter, so if this is the inlet, so this is the pipeline, now this is the how it flows, and this is the outlet, and again this is the pipeline. So now it is flowing like this. So this the vertical distance between the inlet and throat, they have given it as 225 mm. This is first thing. And inlet diameter he has given it as how much, 150 mm, and throat diameter is 75 mm. So the question is, if P1 is the pressure here and P2 is the pressure at the throat, what is P1 minus P2? This is the question. So, but anyhow, our job is always the follows is the only equation which we know is Q is equal to CD into A1 A2 root 2g divided by square root of A1 squared minus A2 squared into root h. So he has already given what is q. Q is equal to well, he has given 0.029. This he has given it as 0.029 meter cube per second, and this he has given it as 0.96. And now A1, A2, basically if you find out what is A1 is pi by 4 into D1 square. If I put it, so D1 is 150 mm. So 150 into 10 to the power of minus 3 meters. So this if I calculate, I'm going to get actually 0.0177 meters square. Then A2 is equal to pi by 4 into D2 75 into 10 to the power of minus 3 whole square. So it is going to be 0.0044 meters square. So A1, A2 is obtained. Then naturally substituting all these things, Q, CD, A1, A2, G. If you substitute, only unknown in the above equation is H. So now if I substitute 0.029 is equal to 0.96. This is 1. And what is A1, A2 root 2G? 0.0177 into 0.0044 into basically into root of 2 into 9.81. This is numerator divided by square root of 0.0177 square minus 0.0044 square into root h. So except that all are known. So find out what is H. H is equal to 2.254 basically meters of oil. So this is what we got. But when the venturi meter is fixed in an inclined pipeline or vertical pipeline, we already mentioned what is H is equal to P1 by gamma plus Z1 minus P2 by gamma plus Z2. This is what we have already mentioned. So if I take it, then it is equal to P1 by gamma minus P2 by gamma basically. Then if I take it plus Z1 minus Z2. This is the thing. So right now, if I take it, what is the difference between Z1 minus Z2? If you take it, Z1 is equal to basically base elevation. Z2 is equal to 225 mm. 225 divided by 1000. So it is 0.225 meters. So this you put it, then actually so therefore h is equal to, already we know 2.254 is equal to p1 by gamma minus p2 by gamma plus z1 is equal to 0 minus point zero 0.02 point sorry 0.225. So if I calculate this, then what is then find out what is p1 by gamma minus sorry P2 by gamma is equal to, then they bring that this side, actually it is going to be 2.254 plus 0.225. It is 2.254 plus 0.225. It is equal to 2.479, right? Then basically next, what is p1 minus p2 by gamma is equal to 2.479. What is p1 minus p2? P1 minus p2 is equal to 2.479 into gamma. What is gamma of petrol? 2.479 into specific gravity, which is given is 0.78 into 9810. So this is specific weight of petrol. So finally you are going to get the answer actually as 18969 Newton per meter square, or it is equal to 18.969 kilonewton per meter square. So this is one type of problem, basically connecting it to, in the case of a vertical or inclined pipeline, what will happen, except remember that h is fixed. Only thing is H is, in the case of horizontal venturi meter, H is equal to P1 by gamma minus P2 by gamma. In the case of an inclined or vertical venturi meter, H is equal to P1 by gamma plus Z1 minus P2 by gamma plus Z2. So this is that means in the case of horizontal venturimeter, it is the pressure difference, whereas in the case of inclined or vertical venturimeter, naturally it should be the piezometric head difference. So apart from that, there is absolutely no change in the other thing. So now let us take the second problem in this venturimeter. A venturimeter is to be fitted in a pipe 0.25 meter diameter where the pressure head is where the pressure head is 7.6 meters of flowing liquid, and the maximum flow is 8.1 meter cube per minute. Find the least diameter. Find the least diameter of the throat to ensure that the pressure head does not become negative. Take CD is equal to 0.96. Kindly remember, some of the people will give C instead of CD. They may call the CD same thing as point K. Some people call it as K, some people call it as C, some people call it as CD. So by looking at the value, you should be able to understand what that being given. So now let us take it straight away, the equation. Given is venturi meter fitted in a pipe of 0.25 meter diameter. Pipe diameter is given. Then next, pressure head at the inlet is given at 7.6 meters actually of flowing liquid. And then discharge is 8.1 meter cube per. Now the question is, what is the diameter of the uh, throat to ensure basically that the pressure at the throat does not become negative. That is what the question is actually. So now basically taking all this into account, let us go ahead straight away with the equation that we have. Now what is the equation that we have? Q is equal to CD into A1 A2 root 2G divided by A1 square minus A2 square into root H. This is the equation for us. Then what is Q for us? They have given it as 8.1 meter cube per minute. But normally what we require, the discharge is always expressed in terms of meter cube per second. So 8.1 meter cube divided by per minute means per second I want by 60. So if I do that, it is 0.135 meter cube per second. This is the first step. Then what is CD he has given? CD is equal to 0.96. Then what is A1 he has given? A1 is equal to pi by 4 into diameter of the pipe is equal to diameter of the inlet. So 0.25 whole square. So it is equal to 0.049 meter square. Then actually he has given H is equal to how much? 7.6 meters. So this is what he has given. So now taking all this into account, so calculate what is now first put it. Q is how much? 0.135 is equal to CD 0.96 into A1 is how much? 0.049 into A2, right, into root 2 into 9.81 divided by a1 square, so that is 0.049 square minus a2 square into root h means root 7. So this is what is being given. Then taking that into account, let us calculate what will be a2, because everything is known except a2. So if you go for it, so a2 is equal to point zero point zero one one two meters square. Therefore, D2 is equal to A2 is equal to, that means pi by 4, D2 square is equal to 0.0112, right? So if you put it, so then D2 is equal to, it is 0 point basically 119 meters. Pressure is, sorry, here it is 7.6. Right. That's it. The remaining all is basically the same. So we will stop the problems at this stage. We have done five problems in the case of the Venturi meter. Now we will go into what is this orifice meter, and let us take actually the orifice meter principle also, and then move ahead actually. So this is the next thing which I am taking. So what is orifice meter? So the next topic is orifice meter. Orifice meter is also again the purpose is to measure the discharge or rate of flow in pipes. This is the fundamental purpose, right? Then naturally orifice meter it is not actually even compared to when compared to venturi meter. uh, the dis- the orifice meter is less accurate. So this is the point that which we need to remember. Then third thing is what is orifice meter? Orifice means what is an orifice? Orifice means a hole made in a plate. Suppose if you imagine that this you have taken a circular plate, so a circular steel plate, if you have taken, if you imagine, and at the center, if you make a hole, basically. So now this is all basically your steel plate, right? Now at the center, you have made a hole actually, right? And this hole is what we call it as orifice. And this entire plate is called as orifice plate. Right? What is an orifice meter? If such an orifice plate is fixed in the pipeline, is fixed in the pipeline. So this device is much cheaper. Venturi meter means you need to have either brass or stainless steel, whatever it is, or gunmetal, that inlet, then the convergent cone throat, the divergent cone, the whole device you need to purchase. But here it is nothing. Just take a steel plate and the circular steel plate, which is, for example, the diameter of the steel plate is equal to, it's a little bit what you call it as a little bit more than the diameter of the pipe, and then actually make a hole at the center, right? So how much diameter hole at the center we should make? Then for example, if you take the pipeline diameter is equal to some 50, that means from what I call it as 20 centimeters, then naturally this whole diameter should be around 10 centimeters. Like in the case of venturi meter, what is the throat diameter to the inlet diameter? What how we maintain it is making at least approximately closer to 50%. So if the inlet is 20 what you call it as centimeters, then the throat the orifice diameter is at whatever you call it as 10 centimeters. So this whole diameter is 10 centimeters, whereas the whole orifice plate size, what diameter is what I call it as a little bit more than the pipe diameter. If the pipe diameter is, for example, 20 centimeters, you take a steel plate of 22 centimeter diameter actually, and then make a hole of 10 centimeters at the middle, and that is, take it and make with flanges, fix it in the pipeline. That is what we call it as an orifice meter. But how it looks like when once we fix it in the pipeline, for example, you take it, suppose this is a pipeline, right? Now let us take a pipe thickness also will be there, right? Now this is the pipe thickness here, and this is the pipe thickness here, just for example. Now what I am asking, actually keep this Orifice. If I put it plate, this will be, this is a. So this is with the flanges actually. We are fixing it at the center. So again, this is pipeline. So these are all basically flanges to fix actually the venturi meter in the pipeline. So this central one is the orifice meter. Right now, if I take it, so this is the pipe. We have fixed the orifice plate at the center like this. So this is fixed. So what is this actually portion is the thickness of the plate. Any stainless steel plate, if you are taking maybe for example 2 mm or 1.5 mm plate, we are taking it. So that 1.5 mm plate, which is a little bit larger than the pipe diameter, we are taking it. And then at the center, we are making a hole. Whatever the thickness 2 mm is there, we making it sharp actually. So that means we are making it beveled actually. So this is how it looks like. Now what I will do, we will fix actually what I call it as one pressure gauge on upstream basically. So here one pressure gauge we are keeping it. So this is one, and second pressure gauge is now the moment water flows into it, the water which is coming here, the flow is taking place like this. This is red marking or flow thing, and now the flow how it moves like this. This is our flow line. So this is how the flow takes place. So now what we will do, we will measure actually at not at the orifice plate, at some point near the orifice plate, we measure the what you call it as the pressure. This is the second gauge. So in the venturimeter, what we have done, we measure at the inlet and we measure at the throat. Now here we don't measure at the throat, a little bit away from the throat we will measure basically the pressure thing. But if you take it, A1 is the area of the pipe, and basic the second thing is orifice area is A0, and the where you are measuring the pressure is what I call it as I call it as A2, right? Where we are measuring the pressure basically. That is A2 if you take it. Now, basically, basic thing is exactly where we are measuring the pressure, there the area, it is very difficult to note this area. How to find out that area is difficult. So that's why what we do, we give the equation. We are not, I'm not doing the derivation again here because it is similar lines to venturimeter, but straight away I give you the equation for what you call it as orifice meter for measuring the discharge. For measuring the discharge, how you are going to do it? So it is only again Q is equal to CD into A0, again A1, right? A0 A1 divided by root 2G divided by square root of A1 square minus A0 square into root H. So we are not in, even though we are measuring the pressure at A2, we are not using that A2. We know whatever is the orifice plate diameter that is there, that we are measuring at the as a second thing. So A0 is the area of the what you call it as the orifice. Then A1 is the area of the inlet, and Q is equal to same formula like venturimeter. And now here remember A1 is the area of pipe and A0 is the area of orifice, orifice plate, right? Then CD is equal to coefficient of discharge, and this CD value for orifice meter will be approximately zero point 0.6, around zero point 0.6 actually. This will be, kindly remember that this is very 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 important. For venturi meter it will be around 0.96 to 0.98, whereas here CD is equal to zero point 0.6. Again, H is nothing but H is equal to, it is P1 by gamma minus P2 by gamma, same. So this is orifice meter. So you can do some more problems in the orifice meter. So I will stop the lecture here, and let us take the next lecture with pitot tube and some problems on the pitot tube. But the problems on the orifice meter is same as venturi meter, except the difference that instead of throat we'd put the area of the orifice. So I will stop the lecture at this point.
Like, share, and subscribe. Hit the bell icon for more updates.